Welding is a huge industry encompassing the manufacturing of a wide variety of products. The welding helmet protects welders from the extremely bright arc flash that occurs during the manufacturing process by using photosensitive resistors to detect the arc and darken the viewing screen. However, welding helmet technology is not perfect and can put professional welders at risk of eye strain and pain due to accidental arc flash. Combining the efforts of senior electrical and mechanical engineering students, we crossed the college boundaries, coming together and analyze the market, identify the problem, design a solution, build, test, and prepare a new, safer welding helmet. For our new welding helmet to be successful, it must meet certain key customer requirements. The helmet must be lightweight, durable, have a good battery life, not hinder the user's functionality, or cause additional problems. We plan to partner with Miller Electric to create an affordable and innovative system that Miller customers can integrate into their current setup to enhance their safety.
The team had to fully understand and benchmark the current Miller system. For optimization and benchmarking, a 3D scan of the helmet was performed and imported into CAD software. The results of the helmet can be seen now.
We took apart the current screen from inside the helmet so we could learn how it works and modify the existing electronics. We had to study the current technology closely to ensure our new design can seamlessly integrate into the current welding accessory market.
An ergonomic assessment of the helmet was conducted by determining the center of gravity and other key features that affect our design.
Our EE team worked through several electronics design iterations, taking it to experts for review, as well as extensive breadboard work and hand calculations. The design was created in 3D modeling software for printing prototypes and ensuring the packaging and fitment of all components.
One key area of focus was battery life improvement. Our prototype lasts 10 times longer than a traditional helmet battery, allowing the welder to focus more on their jobs and less on their charge.
The team overcame the many challenges that come with complex programming, PCB design, CAD design, and design reviews, as well as budgeting limitations, packaging limitations, and working as a team during the COVID-19 pandemic. We've had a fantastic time learning and growing as a team and are incredibly proud of our design we've done to create an innovative and safe product. That's all from the P21511 Auto Darkening Welding Helmet Senior Design Team at Rochester Institute of Technology. Thanks for listening.